Hi guys, Mr. Starry. Today I want to talk about different forms of equations that lines can take. If you remember, lines and equations are directly related. They're built from one another. So as we kind of get further along in this, it's going to be wise of us to be able to understand these different forms of equations, because once we do, it actually makes generating the graph a little quicker and a little easier. So the three forms that I'm talking about are these: slope-intercept form, standard form, and point-slope form. These are the three forms of an equation, or the way an equation can look, so that it can tell us key information so that we're able to generate the graph. Today I just want to concentrate on one, and that's slope-intercept form. Notice that's the first one on our list up here. What is slope-intercept form? Slope-intercept form is this right here. It's any equation that looks like this. Now, the only thing that's going to look different is we're going to have numbers in place of these variables. So instead of this purple m, you'll see a number. Instead of this blue b, you'll see a number. The y equals mx plus b is kind of the entire thing as it's put together, and we'll talk more about that in a little bit. But what is this telling us? Well, first off, notice this is y equals mx plus b. So we're going to try and, if our equations aren't looking like that to start, then we need to make them look like that. And again, we'll talk about that in a little bit here. Well, what is this form telling us? Well, it's telling us two pieces of information that we're going to use to be able to build a graph. It's telling us the slope of our line, and it's telling us the y-intercept. Now, I wish that whoever developed this name would have called this slope y-intercept form, because that's the intercept that it tells us. Remember, there are two intercepts on your traditional coordinate plane. There's the x-intercept and the y-intercept. This is going to tell us the y-intercept. And remember, y-intercept is where your line on your graph crosses the y-axis. Okay, so let's see if we can take a look at a couple equations in slope-intercept form and pull these two pieces of information from them. Things to remember: slope, that's your tilt of your line. Your slope is going to be represented by a number, right? Your y-intercept, that's a location on your graph. So ultimately, we want to have an ordered pair, right? So this is going to be just a number, and this should be some sort of ordered pair. And if you've watched my prior videos, you'll understand that, hey, if I have a starting point and if I have a slope, I should be able to generate a graph. And we'll get into that in later videos. Let's take a look at example number one. Notice, first question we need to ask ourselves is it in slope-intercept form? Well, does it take the form y equals mx plus b? Well, let's take a look here. Y equals, good so far, m, so there's my value for m. X, now notice this says minus, but that's okay. Remember, your kind of rules of adding integers say that, hey, we're allowed to take this and make this plus a negative if we want to, right? So even though that's going to be a minus there, let me change it back to what it originally was. We can still think of that as plus, right? We just kind of have to look at this last number. But again, we'll talk more about that here in a sec. So the two pieces of information I want to pull from this equation are both the slope and the y-intercept. So what are they? Well, let's start with the slope. If I kind of look at slope-intercept form, where is my slope, relatively speaking? It's my coefficient, or my number attached to, or my multiplier of my x. So if I look over here and I say, hey, look, this is the 2/3. The number 2/3 is the number that is attached to the coefficient of, or the multiplier of x. That's my slope. And it's just that, right? So my slope of this line would be 2/3. Now remember, for y-intercept, we need a location. Okay, well, let's take a look here. I like to look at the entirety of this number, meaning we're going to look at the number as a term rather than just the 4, and you'll see what I mean by that here in a sec. So notice that this is plus b. So what does that mean about this minus 4? Well, what this means is my y-intercept is -4. So we need to think visually on a graph, and I'm just going to draw one really quick here. 1, 2, 3, 4, here's my y-axis, right? My line crosses my y-axis at -4. And again, remember, we're talking about y-intercept always here. That's the point of this form, right? We're not going to be talking x-intercept. Well, if my line crosses my y-axis at -4, where is that? Well, that's this ordered pair here, 0, -4. So since this equation's in slope-intercept form, I'm easily able to pull out the slope, which is 2/3, and the y-intercept, which is 0, -4. Let's take a look at the next one. Same idea. Again, my slope is my number that is attached to, or the multiplier of, or the coefficient of my x value. So we look over here, we find my x. What is the number that is being multiplied, the coefficient of, or attached to? That's -7. And remember, it's okay that a slope is a number. That's what it is. If you're going to use rise over run here, it might be wise to put this over 1, but it's not necessary right now because we're not graphing quite yet. Well, let's take a look. What's my y-intercept? Well, again, that's the plus b portion. Well, let's look at this as a whole. This is +3, so I like to think of that as +3. So what's that mean? That means my graph is going to cross my y-axis at +3. It's going to cross my y-axis at +3. Now I'm going to go back to my same graph here. 1, 2, 3. Here's +3 on my y-axis. So what that means is, what is that ordered pair? What's that location? Well, 0, 1, 2, 3. The slope of this line would be -7. The y-intercept of this line would be 0, 3. We have a starting point, we have a slope. From those two pieces of information, we'll be able to generate a line. Let's take a look at a couple more examples. Now notice we're still looking for this form, and let's look at example 3 here. Notice that I don't have y equals mx plus b or anything that kind of looks like that. So let's look at what's really happening. Notice that y is alone by itself on one side of the equal sign. So essentially what I want to do is I want to solve these for y, right? Notice that if you look across here, none of these take this form right here, y equals mx plus b. So there's no way I can just look at this and say, hey, there's the slope, or hey, there's the y-intercept, like I could in my first two examples. So what I need to do is I need to manipulate these equations using solving rules that allow me to turn it into a form like this, because once it's here, then I can pull these two pieces of information off it pretty easily, like we did in the first two examples. Well, let's start. Again, we need to isolate y, right? So again, I like to draw my line. And what's going to happen here is, okay, I want to get rid of this x term first. So using our solving rules, we're going to subtract 5x. Now, notice that those terms will eliminate, and I'm going to be left with -y equals, and notice that -5x and -1 don't combine. They're not like terms. So the best we can do is write them beside each other. -5x minus 1. Now notice I'm not done. I look like I'm close here, right? Because I have -y equals -5x minus 1. And that kind of looks like this, but notice this negative here, that's going to cause problems. So we need a positive y. Well, how do we handle that? When I'm solving, especially more complex solving things like this, I always like to put my 1 in front, my coefficient of 1. Remember, any variable that doesn't have a coefficient has a coefficient of 1, and you have the ability to put that there and take it away. So let's put it there, and notice this is -1 times y. Well, how do I undo that? Well, using our solving rules, I can divide by -1. Well, I'm going to have to do the same thing to everything over here. So divide by -1 as well. What I'm left with over here is y equals -5 divided -5x divided by -1 should give me positive 5x. -1 divided by -1 should give me positive 1. Now, if we take a look at this, this is in slope-intercept form. Y equals my number x plus b, right? Or 1 in this case. So just like our last two examples, we had to do a little work to get it to look like this, but now we're here. So now we can pull off my slope and my y-intercept. Well, again, remember my slope is my number in front of my x. So that's 5 in this case. And remember, my b, or my y-intercept, is kind of, we have to look at this entire last term here. Remember, we're going to include the operation here so that we can remember if it's positive or negative. Notice this is plus 1, so that means my line will cross my y-axis at positive 1. What is that location? 0, 1. And again, we have the two pieces of information we need to make a line. If we look at our next example, it's kind of the same idea here. Notice this isn't slope-intercept form because I don't see this. I don't see y equals a number x plus or minus b. So what I like to do is we'd have to solve this for x again. And I always start with the terms away from my y. Again, solving for y is what we're trying to do here because that's what our formula tells us. Hey, y needs to be alone. Well, let's start taking terms away that are away from my y first. We're going to subtract 2 because that's a positive 2. We need to eliminate that. Those will eliminate. I'm left with positive 2y equals. These won't combine, so the best I can do is write them beside each other. And now I've kind of written x, negative x minus 2. Now, before we take our next step here, kind of like we did over here, I think it's always wise of us to, whenever we see these variables with no coefficient, that we draw that 1 in there. That's going to be helpful in this next part. Now, notice I have 2 times y, so my last step here would be divide by 2. Now remember, everything needs divided by 2. Well, y equals, now the way I like to think of this is I need to do negative 1 divided by 2. And you could definitely write that like this, negative 0.5. Okay, you could do that. However, for our purposes and knowing that we're going to have to graph this, a decimal route probably isn't going to help us here. So let's keep things as a fraction. Well, notice, remember, division is just writing things as fractions, and the opposite, right? Writing fractions as division are the same thing as well. So negative 1 divided by 2, well, that would just be negative 1/2. My x kind of comes along for the ride. Now I need to do negative 2 divided by 2, which is negative 1. Once you've done this, notice y equals mx plus or minus b. Okay, well, we're ready to pull off my slope and my y-intercept. My slope would be my number in front of my x, which is negative 1/2. My y-intercept would be my number out here. And remember, that's a location, negative 1. Okay, just want to backtrack on something here. I'm kind of into this, and I realized I never kind of pointed this out. Remember, we use m to represent the variable slope for slope, and oddly enough, we use b to represent the y-intercept. Don't ask me why it is. I'm not sure, but again, that's kind of where these come from. We use b for y-intercept. We use slope for m for slope. So if you made it this far in the video, sorry about that. I should have cleared that up at the beginning, but we're far enough along here that I think you guys have kind of made sense of that already. Okay, last one here. So again, we're going to try and make it slope-intercept form. This is not slope-intercept form. So here we go. Let's get rid of the terms away from y first. This is a negative 5x, so I'll add 5x, add 5x. That leaves me with 3y equals, excuse me, I'm running out of room here, 5x plus 9. They don't combine because they're not like terms. And again, just like our last one, we have a coefficient of positive 3. We'll divide by 3 on both sides. And we'll get y equals, again, what's a fast way that I can write 5 divided by 3? I can just do 5/3. 5 divided by 3, 5/3. X, not positive 9 divided by 3 should give me positive 3. Now that I'm in slope-intercept form, I have the ability to find the slope and the y-intercept. Remember, my slope is in front of my x. 5/3, that should be a number. And remember, that plus 3 or that positive 3 is a location on my y-axis. So it's wise of me to write it as an ordered pair. So positive 3 on the y-axis would be the location 0, 3. Lots of information in this one, guys. Feel free to rewind, take your time moving through this, watch examples over. But that's all I have for you today. We'll talk to you in the next one.